Hey, um, welcome to another fractions equivalence video. In this one we're going to have a look at adding and subtracting fractions. Now, although you may say that that's not really equivalence, working out equivalent fractions for adding and subtracting is an important part of the process. So let's have a look at some fractions here. I've got two rectangles that has been split into different parts, and some of those parts are blue. Now if I wanted to know what proportion or what fraction of the two rectangles are blue, so what fraction or what proportion of the two rectangles are blue, I'd need to do some addition here. So if we have a look at these and try and express them as fractions, if we asked what fraction of this rectangle is blue, we count up how many parts it's been split into, in this case 8, and how many parts of those are blue? 1, 2, 3. So 3/8 of this whole rectangle are blue. Let's do the same for the other rectangle. Again, we have 1, 2, 3, 4, 5, 6, 7, 8. This rectangle as well has been split into 8 parts, and 1, 2, 3, and 4 of the parts are blue. So 4/8 of them are blue. Now, if I wanted to know what fraction of both rectangles were blue, I would need to essentially add them together. I mean, one thing you ask here is basically how many blue eighths have I got? How many blue eighths have I got? And you could count them up actually. I've got 1, 2, 3, 4, 5, 6, 7. I've got 7/8 which are blue. Now what you've essentially done there is added them together. So when we add fractions together like this, we are saying how many eighths have we got in both cases. So we've got 4/8 in our first one, 3/8 in our first rectangle, and there are 4/8 that are blue in our second rectangle. When we add fractions together, what we do is we add the numerators together, so 4 and 3. The denominator actually stays the same, so we're just adding the top numbers, the numerators, together. So 3 and 4 is 7. The denominator stays the same, which is 8. And the reason that is the case is that you can see up here, actually, like we did at the beginning, what we're asking is how many eighths have we got all together. So that's fairly simple, a fairly straightforward way of doing it. And it works for subtraction as well. You just subtract the numerators and keep the denominators the same. Now that seems fairly simple. The slight problem we run into is when we have a calculation like this. And as you can see here, what we've got are different denominators for each fraction. So if we were following our steps from before, we would add the numerators 3 and 5 together, which would give us 8, and we'd keep the denominator the same. But seeing as we have two denominators here, we run into a little bit of trouble. And it's not just for the method, it's actually the understanding behind it. Because in one we've got 3/4. If we just added the 3 with the 5, we are saying we're adding... Oh dear. Something has gone a little bit wrong here. I apologize. There we go. Now we're back on it. Sorry about that. If we were adding the 3 and the 5 together, what are we adding? 3/4 or 3/16? They represent very different things. So what we need to do in this case, our first step, is that we need to make sure both fractions have a common denominator. Okay, so we need to make sure both fractions have the same denominator. So we need to find a common denominator for that. So like we had a look in the last video of where we are changing one fraction or both fractions so they both have the same common denominator. Now there's a couple of ways we could do that, and I won't go into a huge amount of detail here. If you're not sure, have a look at the videos before. What I'm going to do is I'm going to change this fraction so that it has a denominator of 16, and I'm just going to do that to the side just so I can keep the left hand side clear for my calculations and the right hand for the extra bits that I need to do. So I'm going to change my 3/4 so that it has an equivalent fraction but with 16ths. So once again, ask the question, what have I done here? Well, I've multiplied 4 by 4 to get to 16, and we do the same for the top. So 3 times 4 is 12. So 3/4 equals 12/16. Now my next step is I'm going to rewrite this calculation, but I'm going to change the 3/4 for its equivalent with a denominator of 16. So instead of 3/4, I'm going to put in the new one, which is 12/16, and I'm adding, I don't need to change the second one because it's already got a denominator of 16. So what we have here now is an addition that we can do together. So we have 12/16. There we go. 12/16 plus 5/16. So our third step is the same step that we carried out before. We are going to add the numerators together, because now the denominator is the same, we can just add the numerators together. So 12 plus 5 is 17, and the denominator is 16. So we have 17/16. Now, you may end up with an improper fraction. This is an improper fraction where the numerator is larger than the denominator. Now, we could simplify that to a mixed number, which would be 1 whole and 1/16. Okay, so if we wanted to know how many boxes were blue in this calculation, it would be 1 whole box and then 1/16. So running through those steps again, when we are adding numbers, adding fractions that have different denominators, our first step is we need to identify what the common denominator would be. In this case, the common one would be 16. Our next step is we need to change one or both of the fractions so that they have that denominator. So in this case, we change 3/4 into 12/16. Then our third step is to rewrite the calculation so that we are using those new fractions. So in this case, we change the 3/4 for its equivalent 12/16. Then we add together the numerators because the denominator is the same, and we keep the denominator the same, and that gives us our answer 17/16, or 1 and 1/16. These steps work exactly the same for subtraction, but instead of adding them, you are going to be subtracting the numbers instead of adding them. And that's how we can use our knowledge of equivalent fractions to help us add fractions together. The really key point here when you're adding fractions is you've got to make sure that the denominators are the same, and then you can add them together quite simply. And that's how we add fractions. So until next time, have fun and keep fractioning.